In this video, we're going to look at trig ratios for finding missing parts. In the previous ACT video, we reviewed the trigonometric ratios and defined sine, cosine, tangent, as well as cosecant, secant, and cotangent. And now we're going to take those definitions and those ratios and find some missing pieces here. So our first example says, let's find the value of x in the triangle below given the sine of angle A is equal to 4 over 5 and the cosine of angle A is equal to 3 over 5. Then if you look down here at our triangle ABC, we have this leg AC labeled as x and the hypotenuse is labeled 20. And both of our trig ratios are referring to angle A. So I'm just going to kind of circle angle A because that's the one we're looking at in reference to. Earlier, we labeled it theta. It's all the same thing. And the x is actually next to angle A. That's what we call adjacent. And the 20 is the hypotenuse. And so when I see the words adjacent and hypotenuse, I know that I'm talking about cosine. So I'm going to use the information about cosine to find this missing leg. So if the cosine of angle A is equal to 3 over 5, then that is also equal to x, the adjacent piece, over 20, the hypotenuse. This is all adjacent over hypotenuse, adjacent over hypotenuse. Well, then that looks like a proportion, so we know we just need to cross multiply to solve that. 20 times 3 is 60, equals 5 times x is 5x. Divide by 5 on both sides, 5's cancel, and x is equal to 60 divided by 5 is 12. So x is 12. So this is a good ACT type question because they gave you the information for sine and cosine and you had to figure out that you needed to use cosine. So you got to know your trig ratio definitions. Let's take a look at this one. In the triangle below, what is the length of side A rounded to the nearest hundredth? Okay, this is just a very straightforward trig problem. We're looking for side A. We know we have to use trig because we're missing the hypotenuse as well. If we could use the Pythagorean theorem, we'd use that, but we have to have 2 out of the 3 sides to use the Pythagorean theorem. Here, we only have 1. So we're given this angle here 40 degrees, and with respect to 40 degrees, sorry about that, the opposite side is A, so that's your opposite side, and 6 is next to it, which is adjacent. And if I have opposite and adjacent, then I know I'm using tangent because tangent is defined as the opposite over the adjacent. Now this time I'm giving you the angle, so that goes where the theta is. So we would write this as the tangent of 40 degrees is equal to A, our unknown, over the adjacent piece, 6. Okay, now you're going to need your calculator. So I've pulled mine up, and let's pull it down. We need to find the tangent of 40. And so the tangent of 40, I type in 40 and then I type tangent, depends on what kind of calculator you have. And typically we round this number to 4 decimal places. So I'm going to write the tangent of 40 as 0.8391. I rounded that 0 up to 1 because the number behind it is a 9. So 0.8391. Equals A over 6. And we're solving for A, so we're going to multiply by 6 on both sides. The 6's cancel, and A is equal to, and I'm going to pull out my calculator again, clear out that old stuff, and 0.8391 times 6 is 5.0346. And the direction said round to the hundredths, so 5.03. So that missing side is 5.03. So here we had to identify which trig ratio to use given the angle and the sides. And just a reminder that your angle piece is always this piece right next to your trig ratio. All right, one more. This one's more of a word problem. A real common type problem. A ladder is leaning against a house. A ladder is leaning against a house. The base of the ladder is 3 feet from the house. If the ladder forms a 79-degree angle with the ground, what is the length of the ladder rounded to the nearest hundredth? And then in this problem, they actually gave you some trig ratios. We're going to kind of ignore that first, and we need to draw a picture. So let's just draw a house, real basic. And we need a ladder. We'll make that blue. Leaning up against the house. This is the ground. Right there. Maybe some green grass. Good enough. Okay. Then it says the base, that's the bottom of the ladder, is 3 feet from the house. So from here to here, we're looking at this triangle, that's 3 feet. You can see that would be our right angle. Hopefully you see the right triangle form there, which got me thinking trig. And it says if the ladder forms a 79-degree angle with the ground, that would be right here because that's the ground in green. What's the length of the ladder? Okay, well let's call the length of the ladder x. So with our angle there, 79 degrees, we have the hypotenuse because the ladder is the hypotenuse. So x is the hypotenuse. And then 3 is adjacent to 79. So if I have an adjacent piece and I have a hypotenuse, that tells me I'm using cosine because the cosine of an angle is defined as adjacent over hypotenuse. Okay, so let's solve. The cosine of 79 degrees is equal to adjacent 3 over hypotenuse x. Now you can use your calculator for this, but in this problem they actually gave you the cosine, sine, and tangent of 79. So right here we'll just grab that information. The cosine of 79 degrees is 0.1908 equals 3 over x. Now this is a good problem because look where the x is. The x is in the denominator. So this is a little tricky algebra going on to solve this. What you're going to have to do is get that x out of the bottom. So let's multiply by x on both sides. That way on the right hand side, the x's cancel. And then this leaves me with 0.1908. X is equal to 3. And then I'm just going to divide by 0.1908 on both sides. And those cancel. And then 3 divided by 0.1908. We can get our calculator out for that again. 3 divided by 0.1908 equals, did it tell us where to round to? Nearest hundredth? 15.723, so 15.72. And let's not forget our units. We're talking about feet in this particular problem. So the ladder is 15.72 feet long. So draw your picture, put your angle piece there, or if the angle piece is unknown, and then look at your sides and decide which trig ratio you're going to use.